What is up, Algebra 1? Welcome to another video with Mr. Tokar. This week we are learning about relations and functions. Will you need Desmos? Yes. Do you have lots of stuff to get done this week? Yes. Am I not there? You are correct. I am not there, but we still need to get her done. So, 4.1 is all about two things. They're called relations and functions. Okay, a relation is a set of ordered pairs. Remember, that's a fancy word for points, and all points have an x and a y. We know this, x and y. We call that a coordinate point. X is our input. We put it into the relation, and y is the output. It's what we get out. X is in, y is output. Okay, so here's an example of one way to write a relation. Okay, a relation is made up of two parts: our domain and our range. Domain are all of the x values of our points, and the range is all of our y values. Remember, we can think of this as our inputs. This is what's going in. This is what's coming out. When we put in a 5, we get out a 2. When we put in a 4, out pops a 1 and a 3. When we put in a 3, out pops a 0. When we put in a 2, out pops a 5. And lastly, when you put a 7 into this relation, a 4 comes out. Now, the first thing we need to know is the difference between the domain and the range. The domain, if you don't want to write the whole word, we can use this symbol, capital D or capital R. Domain and range. What are all the elements of the domain? We can write the domain is all of the numbers in the domain. We have a 5, a 4, a 3, a 2, and a 7. This is the domain. It's all those numbers inside of the domain, the x's. The range are all of our numbers in our range, all of the y values. So we write capital R equals our bracket and all of our numbers in the range. 2, 1, 0, 5, 4, and 3. This is our range. Domain is x, range is y. That's the first thing we need to know about our relations and functions. Alright, so these are called mappings. A mapping is where we have an oval on the left. These are our x values, and we have an oval on the right. These are our y values, our input and our output. And our goal is to figure out, when is a relation considered a function? A relation is a function when something special happens, when every input, x value, has only one output. So what that looks like is if I put in a number, so let's look, here's my domain, here's my range. Remember, we can think of it as our x values and our y values. You can think of it as your in and your out. Okay? So if I plug in a -2, the only number that comes out is -5. One input goes to one output. When I plug in 0, the only number that comes out is 2. When I plug in a 1, the only number that comes out is a 2. When I plug in a 5, the only output that comes out is 1. Every single input, every x value, only goes to one number in the output. That means this first mapping, ding, 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 this is a function. Every input had one output. So now let's look at our second one. Again, it's always good to start. Okay, here's my domain. Here's my range. My x, my y, my in, my out. We are trying to make sure every input has one output. -3 outputs 8. One output. So far, so good. -2 is our input. It outputs a 2, and only a 2. So that's good. Now here is where the bad happens. When we input a 1, we get -1 and we get 5. When we input a 1, we can get -1 and we can get 5. Because our input has 2 outputs and not exactly 1, this fails. That means this second one is not a function. This is not a function. Okay, last one. I'm going through. 0 has 1 output. 2 has 1 output. 4 has 1 output. And 6 has 1 output. Even though 2, 4, and 6 all output a 3, that's okay. As long as we don't get 2 outputs. See how the number 1 had 2 arrows that came off of it? That's not good. Here, every input only goes to 1 number. So that is a function. As long as we follow the exactly 1 output rule, we can tell if a relation is a function. Okay, let's do the same thing from our tables. Let's do the same thing for our tables. Okay, now the trick for our table is we always want to look at our x values. Our x values are going to be the dead giveaway. In order for this to have exactly 1 output, we need to make sure that none of our x values repeat. So if I take a look, I have a -2, -1, a 0, and a 1. All of these are different. Since all of our x values are different, this is a function. We only need to look at our x values. If one of our x values repeats, then it fails. Okay, if we look at our next one, we have -2, we have 0, we have another -2, and we have 3. We only care about our x values. The y values don't help us. Now, big problem. I have -2 show up twice. That means -2 has 2 outputs. It outputs a 0 and it outputs -1. If your x value ever repeats, then it instantly fails. This is not a function. Okay, let's do 2 more. If I look, I'm looking only at my x values. That's the only numbers I look at. It does not matter if y repeats. Here, y repeats -1 3 times, and that's okay. We're only looking at x. And I see that x has a 0, a 2, a 4, and a 6. These are all different numbers. So, ding ding, this is a function. Last one, only looking at my x values. Now, when I look through this, I see a big no-no. I see 2 zeros, and I see 2 2s. Our x value repeats 2 different times. There's 2 zeros, 2 2s. That is an instant fail. That means this last one is not a function. And that is how you tell if a table is a function. You only look at your x values. Okay, now let's create a mapping. We are given 1, 2, 3, 4, 5 points, and we are going to create a mapping and decide if this is a function or not. Okay, so here are going to be my x values, and here are my y values. So my x values all go in the left. My y values all go on the right. This is my domain. This is my range. So I just need to plug in a 2, a 5. I'm putting in all my x values. A 7, a 3, and a 2. Now, I already have a 2, so I don't need to write it a second time. Now I'm going to do the same thing for my y values. -1, 5, 3, -1. I already have a -1. I don't need to do it again. And 5. I already have a 5. I don't need to write it again. Now we're going to draw arrows to connect our points. 2 goes to -1. 5 goes to 5. 7 goes to 3. 3 goes to -1. And 2 goes to 5. Okay. Is this a relation? Or is it a function? Let's find out. I'm looking, and right off the bat, I see that 2 goes to 1, and 2 goes to 5. Since 2 goes to 2 different numbers, then this is not a function. 2 has 2 outputs, so that's an immediate fail. Okay, when we're writing our domain, remember our domain is all of our x values. So to write it, we do a capital D, our bracket, and it's all of our x values. 2, 5, 7, 3, bracket. Our range, capital R, draw your bracket, is the y values. -1, 5, and 3, bracket. Okay, here's how we create a mapping. We used our mapping to determine if it is a function, which it wasn't a function, and we know right away I had 2 2's as x values. Since the 2's repeat, it fails. It's not a function. Okay, the last type of problem we are going to do is a super popular OST question. It's going to ask you to complete a table and turn it into a function, or make it not a function. Okay, so our first question has 1, 2, 3, 4 blanks, and we can put in any number we like. So it says, complete the table so the relation is a function. So, to make a relation a function, all we care about the x values. And we just need to make sure we pick all different numbers. As long as none of my x values repeat, I'm good. So I need to just make sure I do not repeat 1 or 3. So I could do 2 and 0. Or I could do 4 and 5. Or 26 and -7. As long as none of these repeat, this is a function. My y values don't matter. We can put in any numbers we like. Second one, complete the table so the relation is not a function. Now it wants me to turn this into a non-function, not a function. That means my x value needs to repeat. So I need to make sure that 1 or 2 other numbers repeat. So if I add a 1 here, it's immediately not a function. We have 2 1s, fails. I could even do another 1. Now it really fails. All 1s, big no-no. Put in any other numbers. Because I have more than 1 1 in my x value, this fails. One more time, let's make it not a function. As long as one of my x values repeats, it fails. So here are my x values. I just need to make a repeating number. I could do a 0 and a 0. And because there are 2 zeros, this fails. The y values don't matter at all. 2 zeros fail. I could do 2 5s. I could do more -3s. If there are 2 numbers that are the same in your x value, it fails. And last but not least, we have the vertical line test. The vertical line test is used to tell if a graph is a function or not. Okay? So we are going to use our pencil. We're going to hold it vertical, which means up and down, like this line over here, up and down. You use your pencil to make a vertical line on the graph, and we are trying to see if it will ever cross our graph at 2 or more points. If it crosses twice or more, it's not a function. If it only ever crosses once, then it's a function. So I'm going to pull up a line. Let's make my line blue. I'll make it a little thicker. Here's my line. You use your pencil. If I take my line and I drag it across, my blue line is only hitting my red line, my red graph, one time. Okay, if I put it here, it only hits once. If I move it over here, this green line, this only hits at 1 point. No matter where I put my vertical line, I will only ever hit my graph once, which means this is a function. If I look at my second one, if I put my line somewhere in the middle, anywhere in here, I can see that my vertical line hits once, twice. 2 hits is an automatic fail. Okay, let's try 2 more. Again, if I take my blue line and I start sliding it across my graph, I can see right away that my line hits not just once, but twice. If I ever hit my graph twice, then fails. Okay? Here, no matter where I put my line, I'm only ever able to hit my graph one time. Since I can only hit the red line one time with a vertical line, this is in fact a function. Okay, last but not least, let's try a couple hard ones. Now, you'll see these graphs have what are called points and holes. If I look right here, this is called a hole. When my vertical line is going through that hole, it does not count as hitting. Okay, here's my pencil, my vertical line. If I put my vertical line where that hole is, it does not count as hitting that line. It falls through the graph and it dies. Okay, so right here, I'm not hitting the graph. It's a hole. Okay, I'm sliding it across, sliding it across, sliding it across, and then all of a sudden right here, my vertical line is hitting 2 points that are filled in. Because I am hitting the graph twice, once, twice, that means this fails my function test. It is not a function. Okay, let's do it again. Starting here, I'm only hitting once, only hitting once, only hitting once, and then all of a sudden right here, it looks like I'm hitting the graph twice. But these are holes, so it does not count. I keep going over, and boom. It looks like I'm hitting twice, but I'm not. The top point is a hole. That does not count as a hit. This does not count. But the bottom one is a solid point. It does count. That's only 1 hit. Keep going over, keep going over. I only ever hit the graph once, so this is a function. Okay, look at our last 2. No matter where I put my line, I'm only ever hitting my graph once, so that is a function. And last but not least, here's a step function. It looks crazy, but no matter where I put my line on here, I'm only ever hitting once. If I put it where there's 2 points, one's a hole, one's a full point, that counts as 1 hit. That counts as only 1 hit. That counts as only 1 hit, because remember, holes count. A point, this counts. A hole does not count. So this is a function. A hole counts as a hit, or a hole does not count as a hit. A solid point does count as a hit. Okay, all I want you to do is I want you to draw your very own function and very own non-function, and we are done with our first part of the notes. Thank you very much, and I'll see you next time.